A wheel balancing stand like this will set you back 500 to 650 bucks. Would you like to be able to print your own for about 20? That's what we're going to do next. And we're also going to make this Arbor. Stick around.
I want you all to remember that I'm just another yokel who's not educated nor a professional in what I'm doing here, and it's possible that if you rely on this video, you, your project, or the both of you might end up as a smoldering hunk of hammered dog shit. Please use common sense, be careful, and always protect your ears, eyes, face, body, and hands when doing this type of work. With that, let's keep on trucking. This video may contain peanuts.
Hello everybody, and welcome to Werner's Whirligigs. I've been working on my 1948 Brown & Sharp No. 2 surface grinder some more, and I'm at a point where I need a wheel balancing stand. Why is that? Because a balanced grinder wheel will make the nicest finish on a ground surface, and that's what I'm striving for. Well, I went online and looked for some balance stands, and they're going to run you around 600 bucks, which is more than I want to spend, especially since that's more than I spent on my surface grinder. So I continued to search, and I found a link to Clow42's video on YouTube where he designs and 3D prints two different styles of surface grinder wheel balancing rigs, and they're really good videos and certainly thoughtful. So I have Fusion 360. I can design my own CAD drawings, and I have a 3D printer. So I designed and printed my own version of this balancing stand. Now, I'm a fan and a subscriber to Clow42, and I think you should check out his video, so I've provided a link in the description below. He does a wonderful job of describing the thought process into designing the balancing stand parts, and he also talks about how he constructed them, and he really did a good job. In addition to that link, there are 5 links below. The first is where to Thingiverse, and you can download the parts to make this for free over there. The next 4 are associate links at Amazon to buy the necessary parts to make this, and that will run you about $20 per unit. But there are some M4 screws and nuts, PETG filament, and ceramic bearings. After we go through this, I'm also going to spend some time making this arbor, this steel arbor, which I turned on my lathe. But I'm going to talk more about that later. All right, well, look. It's still spinning after 2 minutes. I'm pretty happy with these ceramic bearings. So let's move on to the next stage. Vamos!
Let's start at the end. Here's the final product of the wheel balancer contraption. There's 3 distinct pieces. There's this yellow piece which holds the bearings. There's the red piece, which is an A-frame leg, which also provides support for the bearings. And finally, there's this leg support piece, which holds the 2 A-frames together. Now, the purpose of all of this support is to hold these 4 bearings in place. The bearings I've chosen are ceramic bearings, and that is because they have very low friction, very low resistance, and I also will recommend and provide a link below to some dry bearings, ones that ship without lubrication. In this case, we're not moving very fast, and I believe that the lubrication would just provide further resistance or further friction. We want as low friction environment as possible so that the the Arbor can spin freely, and it will allow the heaviest point of the grinding wheel to settle to the bottom. So the Arbor would be placed across here, and then the grinding wheel hangs in the center, and we'll see that a little bit later. I used M4x20 machine screws through each of these points here, and they are captured by M4 nylon lock nuts placed in these holes. Very simple hardware to use. There's a little bit of a trick to installing the nuts, and I'll cover that a little bit later in the video. But all in all, the assembly of this doesn't take all that long, and it provides the support you need in order to get through balancing easily. These parts are going to be over at Thingiverse, and feel free to download them and use them as much as you like. Let me just run through the naming convention really quickly so you understand what you're downloading. This leg support is called leg support. This red piece is called the outside bracket, and the yellow is called the inside bracket. This side and this side are identical, so you'll download 3 files, and you need to print 2 of each of the files, and then you can put it together with machine screws and nuts and bearings, and you'll be done. And here's the parts that came out of the printer, but they still need to be cleaned up.
So the first thing we're going to do is just clean up these parts a little bit. They printed pretty well. You probably can't see it, but this torch is on. And when you're cleaning these up, take special care to clean out this area around where the bearing will sit as much as possible. Even if you have just a few little hairs in there or something, it will create a drag on the bearings, and the tool will lose its sensitivity. So you want the bearings to be spinning as freely as possible. Overall, though, these came out really well. I used OVERTURE black PETG, and I've been using that more and more lately. It's not very expensive. I think on Amazon it's 19 bucks a spool, and it's strong, better, stronger than PLA. I do not have, well, I have tried printing with poly, what is it called? PA, nylon. Whoops. So I have tried with polycarbonate and nylon, and I've had some success. It was something that Prusa made that was specifically for printing polycarbonate without an enclosure, and it worked pretty well. But we'll see. I'm now starting to lust after maybe a bamboo X1C. This printer, my little Mini, my Prusa Mini Plus, has been doing a great job for 3 or maybe it's 4 years now, and still is fantastic. But I'd like to have a bigger print area, and I would also like to be able to have an enclosure and print materials that need an enclosure or require an enclosure, like usually like polycarbonate or nylon. So we'll see. That's not high on the list right now, but it is on the list. I'm using M4 hardware to put this together, and there are links below to find this stuff on Amazon. I always try to do something new each episode, and this time I signed up for an associate's account at eBay so that I can make a penny or two if you guys buy this stuff via my link. Don't feel obligated by any means, but I just wanted to try it out and see if it works. If you do like it and you use the affiliate link, thank you. I think I get maybe 3% of the value of the sale. So these things were like $4 or $5. So what would that be? 5 times 3 at 15 cents per per container here. So I'm putting the nuts in. I chose to go with these recessed lock nuts rather than the those heated nuts that James used on Cloud 42, just because this is easier and quicker. If you watch that video, you'll see he spent a lot of time putting those, sinking those nuts in, and while yes, it does look good, it doesn't look so good that I want to spend the time doing that. Of course, now I'm stuck with trying to get these things in V3, which is actually going to be V11. I am going to put some soft edges around here so I can get these nuts in more easily. But for now, I'm just going to have to suffer through it. And I don't think I'm going to make you suffer through it. So I'll be back once I get all the nuts in. Now, I did find a little trick for putting these in. Just need to get them started in the hole, which in and of itself is not that easy, but once you get them to lock in ever so slightly, you can just take a pair of pliers like this and just see, these don't have any teeth on it, so they don't mar the surface. And I'm just putting a little bit of pressure on it, and that gets it pushed in there. So that's might be a better way to go, but in the next version, which will be the one that is distributed, I've chamfered the edges so that this job or this task doesn't become such a pain in the butt. We now have all the nuts in place, and I've actually started all of the 4mm machine screws as well, just to save some time. So let's start. First thing I would do, and the first thing I do, is I test the fit of this inside bracket to the outside bracket. Just put it in here and click it into place, and it actually should snap into place. Just make sure it fits well. They usually do, but if they don't, you might have a piece of plastic or something in there interfering. Take the bearing, one bearing, doesn't matter which way it goes, and put it onto the 2 posts, and then put it into place. And then what we're going to do is we're just going to tighten these top 2 screws. And I'm going to come through and tighten everything all the way by snug it by hand. So just for now, it's loosely torqued. And then check the bearings to make sure that they both continue to spin. It'll be obvious if there's interference, but you want to do that now. And if there is, you might have a piece of plastic hanging out around the edge or something, but it usually comes down to, yeah, some piece of trash in there that is dragging the bearing. Okay, we'll grab the second one, put it on. Actually, now, yeah, first we'll click it into place. Good fit. Put on the bearings. Click them into place. Tighten down the screws. Okay. Test the spinning. They're doing just fine. Okay, now we're going to take on one of the arms. Now, these arms just, you know, they have a, they don't have a flat top here. They have a curve here, an arc, and that is so that when it's installed, it goes safely around the inside bracket here. So just keep that in mind when you're lining it up. And also with these, don't tighten them up all the way, because there's going to be one last step where we make sure that it sits on the ground level. There is a tendency sometimes for two of the corners to be higher, two of the opposing corners to be higher, and when that happens, then it rocks back and forth. Not doing it now, but it would rock something like, well, go dink, 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 dink. We don't want that. Okay, let's get the next one in. Alright, let's just see how it fits. Okay, see, this one is rocking a little bit. So these legs are high, these legs are low, and so it's rocking back and forth. So what I've done, what I've been doing, is I loosen the low leg, just one of them for now, and then let's pretend we're pushing it down into the ground because it's too high. So you put your thumb on the underside of the leg support and these two fingers on top, and then just push down a little bit and then tighten. You don't have to push a lot, but just enough that it, you know, you can feel a little bit of displacement. Let's try again. Okay, see, now it's solid. Let's go around and then just tighten up the rest of these by hand. You know, one of these things new, made out of steel, probably will run you at least 650 bucks from somebody like Sopco, which makes incredible tools. So anyways, you know, the total cost on this is like something like 20 bucks when you take into account the filament, the bearings, nice bearings, and some machine screws. So let's check it again for balance. Still got a little bit of a rock, so let's see. I think we did this one before, so let's turn this one around. Nope, we did that one before, I can just tell. So we'll loosen this just a hair. And again, just apply a little bit of pressure. Okay, better. Final test on the bearings. Alright, everything is spinning. This one bearing is not as happy. Of the four, this one seems to be the weakest. Okay. One thing I want to mention about bearings is that I actually tried out several different types of bearings. I made one of these early on with these bearings that are black and red, and they are also ceramic bearings, just like these white VXB ceramic bearings, but I believe that these perform better. I don't have the means to do a scientific test, but I did put an arbor on here and spin it and record the time. I put an arbor on here and spun it and recorded the time. And I did that over and over. Of course, I cannot correct for, how hard I hit it with my hand, so it's certainly not scientific, but every single time, even when I tried to back off a little bit on this one, these spun longer. I think that means they're better because they have less friction, and I would recommend using these. Now, in the video, I use these white ones because that's what I had here in my shop. I ordered another set of these, but they only got here last night, and I'd already made the entire video by then. So now that you know, when you look in the description below, I will put both of them in there, but get these. They're $14 for a set of 4. These are $8 a piece, so $32 for a set of 4. For less than half the price, you get a better functioning bearing, in my humble opinion. Well, now that we have a wheel balancing stand, we're going to need an arbor to mount the wheel adapter, which holds the grinding wheel. And it's reverse threaded. Now I cut this piece out of steel 12L14 on my lathe, and that's where we're going to go next. Let me give you a brief introduction to my lathe, and I apologize if it's making noise, we'll see, but that's my rotary phase converter running in the background because this is a 3-phase lathe. This is my Victor 1630. They make a 1640, but a deal came up on a 1630 that I just could not pass up, so that's what I have. And it's a fairly stout piece of machinery. I think it weighs about 2,600 pounds, and it's got some water cooling, which I have not used. And what else? Plenty of speeds, high, low, reverse, thread cutting in inches. And then I have to make, which is probably a future project, a couple of gears just so that I can get more metric threading capacity. So it's not like I have to have a different set of gears for each individual thread for metric. I just need to make 2 or maybe 3 gears. And like I said, I'll get around to that. Anyway, the reason that we are showcasing this for the very first time on my channel is that we're going to be cutting a taper today on the Arbor for the wheel adapter for the surface grinder. All right, let's go. I've got this piece of 12L14 in my lathe, and I'm ready to clean the end off and put a hole in the end so I can put my live center in there. is the end of this first part. Now I'm going to pop the 3 jaws open. Oops. Run it at low speed real quick. That looks good to me. Thankfully, this thing does not need to be super precise. It's just a taper on a steel shaft. I'd like to have about 2.5 inches on either side of the taper, and the overall tool is going to be 7.5 inches long. So I'm just going to mark a couple of lines where the ends of the taper will end up being. And this is obviously not very precise, but it's all I need. What I'm going to do first is turn down the 2 sides here and here till they're approximately 1/2 inch in diameter. So I'll start there. $354. Wow. That can't be. 5000. All right, now it's 4.9995. No, that's cool. All right, 500, and that's 500. Perfect. Sweet. Okay, I've got a parting tool on there now, just so I can start cutting in and make room for my my cutting tool to come back the other way and build out the shaft on this side, or cut out the shaft on this side. Alright, whoop. Having light problems here. We're at 0.625. I think I'll leave it there for now, put on a different cutter. Well, I'm not sure of a better way to do this, so I'm just going to take off the top layers, and then from the center I'll work out to create the other side of the shaft. That's 5000000. I'll take it. I gotta go in the other direction and finish it up. Now I probably cut that too small, but we'll see. Yep, just a hair. 499940. Now we need to cut the taper. So regarding this taper, before I started doing all this cutting, I set up my compound slide at the appropriate angle. There is a fantastic video by Joe Pye, which I will link below, which will show you how to set up your compound slide really precisely. So what I will tell you is that the taper is 3 inches per foot, and doing some trig, that works out to a 7.125 degree angle. Actually, the included angle would be, or in other words, the included angle of the taper from side to side would be twice that. But since we are cutting on one side, we need to do half of that. So it's, again, 7.125. And now, on with the show. Well, I don't believe it. And at the same time I do. I forgot to turn the camera on for cutting the taper. Yeah, you could see it came out really nicely. But yeah, that was dumb. Dragged you guys all the way across hell and back, and then right before we got to the finish line, I failed. Sorry guys. Still have a little bit of cleaning up here to do on this piece, so I'm just gonna cut a couple chamfers around some edges and then part it off. So okay, let's just do a little chamfering. This is my feeble attempt to catch it without sending it flying. Well, that was not a proud moment, but good enough. Well, you know, I'm sorry again that I forgot to hit the go button on my camera when I was cutting the taper. It's about the dumbest thing ever. Oh well. So here it is. I do not yet have a Arbor that has balancing weights on it. I just have the one that was originally on this machine. But just for fun, let's hook it up. So put that in there. Okay. Stick this on here. And let's see what happens. It should just rotate until the heaviest part is at the bottom. And hopefully it'll rock back and forth a little bit, because that just means that the bearings are working well. Okay. All right, that doesn't look too bad. I mean, just in terms of the amount of movement afforded by these ceramic bearings. You know, if it had just rolled over once and stopped, I would have been I would have been disappointed. So one other thing, let's just give it a spin and see how long it spins. That's not too fast, but let's just see how good these ceramic bearings are when they have a little more weight on them driving the rotation. That is a long time. That had to be at least several minutes. That's my air compressor. Oh. Well, as luck would have it, my balancing adapter showed up in the mail today. I'll give you a closer look here. There, well, here we go. And it's got these 3 weights here that you can move around to balance the wheel. Unfortunately, and I didn't realize this, the diameter, the exterior diameter here is much larger than the Brown and Sharp, and this is not going to work. It's not going to fit. It's not going to fit on my surface grinder. However, we're just going to use it real quick to balance this wheel. So I'm just going to put it up here and let it settle down to the low point. Okay, there we go. So I'm going to make a little mark at the light point, I guess. All right, and then we're going to move the weights up towards the light point, so it'll balance the heavy side down below. So move that up a little bit and try again. All right, it appears that it's still the heavy point, so we'll loosen the weight and move it again. Wow, okay. Well, it's still the heavy point. Hopefully I have enough. I don't run out of room here. There we go. Okay, so now we've moved it over the heavy, or here's the light point here. So what? I think we need to move this one up now. Just a little bit. Oh. Okay, it's sitting there now. Let's rotate it 90 degrees and see what happens. All right, still balanced. Still balanced. Still balanced. Still balanced. Okay, I think this wheel is now balanced. If it were the right sized adapter, I could go mount it on the surface grinder and begin to use it. But unfortunately, because of this large diameter here, I won't have the clearance. So back to the drawing board. I've got to figure out a different solution, and that will be in the next video. Well, that's another video done and dusted, and I'm really happy with how these turned out. Again, I apologize for forgetting to turn on the camera. Actually, what happened was I thought I had turned off the camera and then thought I was turning it back on, but I hadn't turned it off, so when I turned it back on, I was turning it off. Brilliant. Anyway, so don't forget you can download these files on Thingiverse if you would like to print your own, and there are also links below to Amazon where you can quickly just click and buy the nuts and the screws and the bearings and even the filament if you'd like. Moving on, I looked at a balancing arbor. A balancing arbor is essentially what I have, but it also has the weights built into it, like that one I was testing towards the end of the video. Anyways, that one didn't fit, so I went to Sopco and looked for a new one, and they're $340, which is just out of my league as a hobbyist, and as far as how much I want to spend on this project. I did notice that Sopco is selling brand new ones through Travers that are not balanced or balancing adapters for $78. That's much more reasonable, and I may end up going with that. But for now, what I'm going to do is I'm going to make my own balancing weights to use on my existing arbor, which I believe, after looking at it more closely, is actually a Sopco arbor. I don't think it's the original one from Brown and Sharp, but I don't know for sure. But it really does look more like a Sopco unit. So, I want to get this done. I have these two vices here. They've been sitting here for now exactly 2 months. And of course, I want to get that back to them, but I can't do it until I get this surface grinder up and running. So, well, wish me luck that I get it done soon. All right, guys, I'll see you at the next one. So long for now.